How big is the Earth? And how can you use a shadow to work it out? In this video, we'll see how a Greek scholar over 2,000 years ago worked out a pretty good estimate of what we know it of today. Eratosthenes was a Greek mathematician, a geographer, a poet, and also an astronomer. Now, it was he who calculated the circumference of the Earth first, at least by any known historical documents, and here was his method. Now, he lived in the city of Alexandria, near the mouth of the Nile River by the Mediterranean coast in northern Egypt. He knew that on a certain day each year, the summer solstice, in the town of Syene in southern Egypt, there was no shadow at the bottom of a well. He realized that what this meant was that the sun was directly overhead in Syene at noon on that day each year. Now, he also knew that the sun was never directly overhead, even on the summer solstice, in his home city of Alexandria, which is further north than Syene. And he realized that he could determine how far away from directly overhead the sun was in Alexandria by measuring the angle formed by a shadow from a vertical object. So he measured the length of the shadow of a very tall tower and used simple geometry to calculate the angle between the shadow and the vertical tower. And this angle turned out to be very close to 7.2 degrees. Next, he used a bit more geometry to reason that the shadow's angle would be the same as the angle between Alexandria and Syene as measured from the Earth's center. Now, conveniently, 7.2 degrees is 1/50th of a full circle. 50 by 7.2 is 360 degrees. And he understood that if he could determine the distance between Alexandria and Syene, all he would have to do would be to multiply that distance by 50 to find the circumference of the whole Earth. Now, his calculation using this method could have varied at that time by between 1 and 15%, depending on the measurements used, because unfortunately there wasn't a universal constant about the distance, but it was still an amazing achievement using just logic, geometry, and shadows. One thing that his calculation also implied was the Earth itself was a perfect sphere, and that is not actually the case. Since the Earth is spinning on its axis, it actually bulges out in the middle and therefore is slightly flatter at the poles. It's actually what's known as an oblate spheroid. And it was another mathematician, this time from India, called Aryabhata, who realized the implications of the spinning effect. And he calculated the size of the Earth to just 67 miles from what we know it today, and this was in 600 AD. Frederick Robert Helmont in 1902 determined the Earth was a global ellipsoid, and he calculated the circumference to 100 meters, or just 0.0002% of what our modern measurements are. In fact, it's only since the invention of space travel and mapping the Earth with extremely precise instruments that we've improved on his calculation. As it stands, the measurements as we know them today is that the Earth has a radius of 3,963 miles, or 6,387 kilometers at the equator. At the poles, though, it's 3,949 miles, or 6,356 kilometers. This gives us a circumference of 24,900 miles, or 40,070 kilometers at the equator, but pole to pole, or what's known as the meridional circumference, Earth is only 24,812 miles, or 39,931 kilometers. And that is how we can measure almost perfectly the size of the Earth from just using shadows. Join me again next time on 5Ws and 1H. Click subscribe if you haven't already. And in the meantime, shoot me an email at 5Ws and 1H@gmail.com. And I'll see you on the next video.